Hello students, welcome back. So in this video, again I'm back with the lines and angle, class 9. So we'll start with basic terminations, basic definitions that we have in this chapter. You would have done all these in your 7th grade. So let's start with those basic terminology that we'll be using over here in the chapter. First thing is, what is a line segment? I think you all know very well that if I draw a line AB, it has to be a straight line. Mine is not a straight over here. So this straight line AB is a line segment. If it has a fixed length, 4 centimeter, that's a line segment, and we represent line segment like this. Now, if I make a ray like that, that's AB is a ray, and how do I represent it? AB with an arrow. A is the starting point, B is the point. It keeps on going. Array has only one start point, or you can say end point. A line segment has two end points. A line we generally represent like this with two arrows because it's has no fixed length. That's a line. Now on a line, if I put some points, let's say I have a line xy. On that, if I put some point over here, let's say z. So these points are on the same line, x, z, y. So they all are collinear points because they're on same line. But if I put a point over here, let's say a, so this a is non-collinear with x, z, and y. Okay. So I hope this concept of line segment, ray, collinear, non-collinear is clear. Now let's move to angle. Now how an angle is formed? You have a ray, let's say, I'll say OA. Now when this A rotates, this ray goes over here. Let's say it moves over here and comes to this point, and I mark it as B. So this is an angle being formed. Okay. So the angle is formed by two rays OB and OA. Fine, both are from the same point, end point. So these two rays are called the arms of the angle, and this point where they meet is called their vertex, and we got an angle. Okay. Now angle is formed, so we have different type of angles. Let's talk about all different type of angles once. We have the acute angle when angle is between 0 to 90 degree. Right angle, you all know that's a right angle, which is 90 degree. More than 90 degree to 180 is obtuse angle. Straight line, this angle if I check, that's called as straight angle, or it's a straight line. On straight line you get a straight angle. Now angle more than 180 but it's less than 360 degrees called as reflex angle. And if we complete the whole circle, let's say from here we move completely, so that angle is called as complete angle, which is equals to 360 degrees. I hope that's clear. Now let's talk about the terms which is known as complementary angles and supplementary angles. So students, I think you know that two angles if I take and their sum is 90 degree. Let's say 45 plus 45 you know is 90, so these two are complementary. 60 plus 30, 90, these two are complementary. Okay, if I take 70 degrees plus 20 degree, that's also 90. So 70 is a complement of 20, 20 is the complement of 70. This is how we say 70 and 20 are both complementary angles of each other. Okay, because their sum is together 90 degree. Now let's move to supplementary angles. Two angles whose sum come out to be 180 degree. They are called as supplementary angles. Let's say easiest example, 120 degree plus 60 degree comes out to be 180 degree. So they both are supplementary to each other. Fine. 110 plus 70, they both are also supplementary to each other. These type of angles are supplementary. I hope the concept is clear, students. We talked about line segment, we talked about array, we talked about collinear points, non-collinear points, angle, the vertex of the angle, and different type of angles. Okay, students, let us now move to the next thing. Now, the two angles, if you see this figure, let's talk about this figure. You see here how many angles are being formed? 1, 2, and the last one is this third angle, ABC. Fine. I have ABD, I have BDC. Now when I see over here, this BD is common ray for both these two angles, angle 1 and angle 2. So as these two angles have a common ray, they are called as adjacent angles. Okay, adjacent is that one of the angle is touching the boundary of the other one. If you check, yes or no. So this ABD, one ray is overlapping over here. So they both angles are adjacent angles. I hope this is clear, students. Now let's move to linear pair. Now what is this linear pair? Linear pair is on a straight line. You see this is AC is ABC is a straight line. On a straight line I have a ray BD. Now this ray is dividing this straight line into two equal angles, two parts, not equal, sorry. So you see, let's say this is 1, this is 2. So this 1 plus 2 is how much? You know that's ABC is a straight line. So straight line is 180 degree. So this sum of angles, two sum of angles coming out to be 180 degree, meaning one thing is they are supplementary angles, another thing they make a linear pair. Understood what a linear pair is? That on a straight line, when a ray dividing the straight line into two angles, you get a linear pair over there. Fine, students. Now let's see what are vertically opposite angles. You see over here there are two lines intersecting each other at a point O. When two lines intersect each other at a single point O, we get four angles over here. And what do we call them as? These two opposite are known as vertically opposite angles. And we denote this by VOA. 1 and 2. So angle 1 equals to angle 2. This is, let's say, 3, 4. So angle 3 equals to angle 4. Reason? Because they're vertically opposite angle. We'll be using this and we'll be proving it as a theorem also, that how they're equal. Till now you have learned that these vertically opposite angles are always equal. We will prove it also how they're equal in the next section of the same video. Okay, students. Now let's move to lines also. See, when you draw two lines, yeah, you see in this figure, this is 6.51, this is 6.52. Okay, you see when you draw two lines, PQ, RS, you see they are intersecting at a point. So these lines are called as intersecting lines as they're meeting at one point. Now, what about these two lines? They're not meeting at one point. The distance between them remains the same. They are non-intersecting and they are parallel lines. What are these lines, students? They are parallel lines. So we have intersecting lines, we have parallel lines. In this chapter, we are going to find out angles in the figures which will be given based on intersecting lines, based on parallel lines, mixed of those figures also. Okay, students? Fine. So to do those things, we'll be using all these stuff, linear pair, vertically opposite angles, adjacent angles, different type of angles, everything will be used over there to solve those questions. Fine. So the basic concept should be clear. You should know all about all the different type of angles. Okay, students. Let us now proceed to the next section. Now, in ninth grade, you will come across theorems. You have to prove them. Like there are some statements which you need to prove. And there are some statements that you are going to always assume which are always true. What can be true over here? Let's see. Like those statements which are always true, you assume them to be true and you use those to prove your theorems. So those statements are called as axioms. What are they called as? Axiom. An axiom, postulate, or it's basically an assumption, is a statement that is taken to be true. And we use these axioms to prove our theorems further or to solve our questions. Clear, students? Now, there are two axioms for this exercise or for this chapter that we are going to use over here is axiom 6.1, which says that if a ray stands on a line, like I have a straight line, okay, on this straight line, let's say it's AB, there is a ray standing. Let me name that ray as OC. Then you see there are two adjacent angles being formed, AOC and what is the other one? BOC. These two adjacent angles so formed add equals to 180 degrees. Okay. The sum of these two adjacent angles is equals to 180 degree. Clear? So whenever you have a ray standing on a straight line, we got two adjacent angles whose sum is 180 degree. Clear? Second axiom, if sum of two adjacent angles is 180 degree, okay, you have given two adjacent angles, let's say like this I'm taking now. Fine. I have this line as X, this line as Y, this is O and Z. Now it is given to you that YOZ plus XOZ is 180 degree. Okay. the sum of these two adjacent angles is 180 degree, it means XOY is a straight line. Okay, XOY is a line. Clear, students? Same thing but said in different way. One way is that on a straight line, if you have a ray and you're getting adjacent angles whose sum is 180, yeah, on a straight line, if you have a ray, the sum of the two adjacent angles will be 180. Then second one, if on a line the sum of two adjacent angles comes out to be 180, then that line is a straight line. Clear? Okay, students, I hope that's clear to you. Now, these two axioms, if you see, they are related to linear pair. Am I right? We talked about linear pair. So these two axioms together are called as linear pair axiom. Clear? Now let's move to the first theorem of the chapter and we will prove it. So students, whenever we prove a theorem, make it sure that you draw the figure for the theorem. Fine, because you will have statement that prove that if two lines intersect each other, then the vertically opposite angles are equal. So we are supposed to first draw the figure for that. Okay, so I have the figure over here. So let's say in every theorem when you prove, you have to write what is given to you. So I'll say let AB and CD are the two lines intersecting at O. Fine, this is given to me that the two lines intersect each other. Fine, I'll just mention the name of the lines and I'll mention the point of intersection. Then what do I have to prove? I have to mention there. It is saying that vertically opposite angles are equal. So what are all vertically opposite angles over here? AOD. You need to prove AOD equals to BOC. You also have to prove AOC equals to BOD. Clear, students? You need to write given, you need to write to prove. Let's start with the proof. How will I prove it? I'll be using this linear pair axiom. Yeah. How will I start it? Let's say CD is a line. Yes, students. As CD is a line, I'm having two adjacent angles AOC plus AOD is 180 degree. Reason is linear pair axiom. You either write only linear pair or linear pair axiom completely. Both are same thing. Fine. Okay. So I'll mark it as equation 1. Now AB is also a line. Yes or no, students? AB is also a line. So I'll say again that AOD is equals to, not equals to, sorry, AOD plus DOB is 180 degree. That's my second equation. Same reason, linear pair axiom. Clear, students? Now 1 and 2 both are 180 degree. So can I say that from 1 and 2 I'll write angle AOC plus angle AOD is equals to angle AOD plus angle DOB. Clear, students, what I did over here? Any doubt till now? I hope you people are understanding. So you see, from 1 and 2, as both the things are equals to 180, so I equated them. Simply, I did that. Now AOD, AOD, same thing on both the sides. I can cancel them. So what do I get? AOC is equals to DOB. AOC equals to DOB. I got the vertically pair opposite angle. Yeah, AOC equals to BOD or DOB, same thing came. Fine, students. Similarly, you don't have to prove the other part. You can write that AOD equals to BOC also. Okay, similarly, angle AOD equals to BOC and hence proved. As both the parts are almost same, you have to write the same thing, just the angle names will be different. So you can say similarly. Got, students? Because the same steps are there, you can use similarly over here. I only proved the one thing, two angles equal, rest two will be similarly equal. Students, clear? All the steps? No doubt? Now I'm moving to the exercise. Okay, let's start with the exercise. Let's start with question number 1 of exercise 6.1. Let's again a very easy thing. You see over here, line AB, line CD. They both intersect at this point O. Angle AOC, this is the angle, plus angle BOE is given to 70. Both of them add up to 70. BOD is given as how much? 40 degrees. Okay. I need to find BOE. This one I have to find. And I have to find reflex of COE. Reflex of COE means I have to complete 360 minus all the angles. You will get COE. Now, how will you start it, students? First, you can see over here that angle AOC is equals to angle BOD. Can I say that thing? The reason for that is what? What's the reason for that? Vertically opposite angles. If you see AB is a line, CD is a line, they both intersect. So these two angles formed are vertically opposite angles. Okay. So I got this AOC also as 40 degree. Fine. Now what is given to you in the question that AOC plus BOE is 70 degree. AOC I got. So what will be BOE? That will be 70 minus 40. That's 30 degree. You got your first part over here. Clear, student? 30 degrees there. Now, you have this as 40, this as 30, no need for that also. Well, how will you get COE? You know that AOC plus COE plus BOE, that's 180 degree. Can I say? I think we missed this thing. These are sum of all angles on a straight line. Yes or no? On a straight line, you take any number of angles, but when you add all of them, they will be 180 only. Okay, so I will get COE is equals to 180 minus this AOC and BOE, this thing, not this part. They both are given equals to 70 degrees. So that's minus 70. It comes out to be 110 degree. So that's my COE. COE is 110 degree. So what's reflex of COE? Reflex of angle COE is 360 minus 110. Reflex you get like that only. So it's 0, 6 minus 1, 5, 3 minus 1, 2. It's 250 degrees. Clear, students? We got BOE as 30 degree. That's my answer. And COE as 250 degrees. I hope this step is also clear, students. Yes or no? Fine. So now let's move to the next question of the exercise. Here also in the figure we have intersecting lines at point O. Two lines are there, XY and MN. Now angle POY, that's 90 degree, and this symbol also means it's a 90 degree angle. Ratio of A is to B is 2 is to 3. Now if you see over here also, students, that XY is a line. Am I right? XY is a line. Okay. So POX plus POY is 180 degrees. Sorry. Okay, that's again linear pair. Fine. So I'll get POX is equals to 90 degree because 180 minus 90, this will whole comes out to be 90 degree. Now what is this POX? POX is basically POM plus MOX. Fine. What's that? A and B. Am I right or wrong? That's A and B. But A and B are given as 2 is to 3, the ratio. So I'll say A is 2x, B is 3x. Fine. So 5x is 90 degrees. So from x comes out to be 90 by 5. How much is 90 by 5? So you divide. 5 ones are 5. 4 goes over 18. X comes out to be 18. Okay. So what will be the values of A and B? So A will be 18 into 2. So that's 36 degrees. And B will be 18 into 3. That's 54 degrees. You got A and B now. Now A and B is there. You have to find C. Finding C is easy. You know MN is a line if you check. Yeah. So this B and C. So B plus C is 180 degrees. Linear pair again. Yeah. So what will be C? 180 minus 54. B is 54. We just calculated. So 10 minus 4 is 6. 7 minus 5 is 2. C comes out to be 126 degrees. I hope that's clear, students. Yeah, we got C. Okay, there are many ways to find it out also. Okay, you can get it vertically opposite, that way, any way you found, it will be done. Okay, so it's up to you which method you use and how you start with, and you have to come up with the same answer and correct answer. Okay, students, I hope this is also clear. Let's now move to the next question. That's also an easy question. Over here, if you see in this figure, you don't have an intersecting line over here. You have angles given over here. It's a triangle over here. Yeah, this PQR and PRQ. They both are equal. Okay, but you see, these are rays meeting at one point. Okay, but QP, PR, so they are converted into line segments over here. Now, if you see over here, this angle and this angle, they make linear pairs. Am I right or wrong? So I can write that angle PQS plus angle PQR is 180 degree. That's linear pair. Okay, students? Yeah, that's my equation 1. Same way I'll say PRT plus PRQ angles, that is also 180 degree. Again, linear pair. Okay, that's my second equation. This and this add up to 180, PQS, PQR. Then PRT, PRQ. That's also 180 degree. Now, as both the sum are equal to 180 degrees, so again I'll do the same thing from 1 and 2. I'll equate them. PQS plus PQR is equals to PRT plus PRQ. Now, something is given equal to us, am I right? So, PQR is equals to PRQ. I can cancel equal things. Yeah. So, what am I left with? PQS is equals to angle PRT. Angle PQS is equals to angle PRT. This is what we have to prove. Yeah, students? This is what we have to prove. Done. Very easy question. Let's now move to the next question, fourth question of the exercise. How will we do this? We have to prove that AOB is a line. It's not given to us that AOB is a line. Now for this thing, we will use another theorem, we can say, or a thing, that sum of all angles at a point. Sum of all angles at a point is how much? 360 degree. That is what we are going to use over here. Fine, students? So what are all angles over here on this thing? 1 point, x plus y plus z plus w is 360 degree. That is the reason I have done it. Now x plus y is given equals to. So instead of that, I'll write w plus z plus w is 360 degree. Reason you will write that x plus y is equals to w plus z, that's given. Okay, students. Now 2w plus 2z is equals to 360 degrees. Take 2 common. W plus z 360 degrees. So W plus Z will be 360 by 2, which is 180 degrees. Now W plus Z are what? They are adjacent angles. Yeah. So W and Z are adjacent angles on a straight line. Okay. Fine. Clear, students? So by converse means opposite. Converse of linear pair axiom, you will have what? AB is a line. Fine, students. Now let's move to the next question. I hope this is also clear. Very important question of the exercise this is. Okay, just understand how we will be solving it. Yeah. So here, what is given to you? Whenever you have proving question, right, what is given to you? It's POQ is a line. Okay, and OR is perpendicular to PQ. Okay, fine, students. This is what all given to you. Fine. Now let's write what do you have to prove. Again, one more thing is there, that OS is a ray. Okay, fine. OS is a ray on PQ, another ray on PQ. Fine. Now you have to prove is angle ROS is equals to half of angle QOS minus POS. There are different ways of doing this, students. Whatever way you start, That's is what comes to your mind. Okay, let's start with an easy way only. Over here, what do you have? One thing you have is that angle POR plus angle QOR is what? 180 degree. Am I right, students? That's a linear pair. Okay, fine. Yeah. Now, I have angle POR is what? Angle POR is equals to angle POS plus angle ROS. Fine, students. What is POR? POR is POS plus ROS. Fine. And now what is your QOS? QOS is QOR plus SOR or ROS. Fine, students. Can I write all this? Fine. Done with this also? Okay. Now if you check this POR and QOR from this only I'll say because they both are 90. Yeah, they both are 90, 90 over here. Okay, so I'll just put their values. Fine. So in this one I'll do first. So that POR is how much? 90 degree is equals to POS plus ROS. Fine. Here, let me just bring it, reshuffle it over here and there. Okay. So I will have first QOR is equals to QOS minus ROS. Fine. But this QOR is also 90 degree and that's QOS minus ROS. So that's my first equation. That's my second. I can equate them because both of them are 90. Yeah. Both of them are 90. So I have POS plus ROS is equals to QoS minus ROS. Clear, students? Hope this is clear till here. Now, let's move it over here and there. Bring ROS on same side, ROS plus ROS, okay? And take this POS on this side. Transposition I did. So 2 ROS is equals to QoS minus POS. This 2 I can take down over here. QoS minus angle POS. Hence, proved. I think this is what we have to prove. Yeah, yeah. ROS is equals to half of QoS minus POS. Hope it's clear, students. No doubt. Fine. Now let's move to the next question. Let's just finish it up faster. So here the figure is not given. So many questions in the exam you will see that figure is not there. You have to draw the figure. Okay, and it's written over here also draw. So don't draw the figure in rough. That should be a fair figure for all the questions. For all the questions, you have to draw the figure. Okay, so let's start with it. So it says that we have a ray YQ bisects this. So let's start with XYZ. Let me make an angle first, XYZ. So it's an acute angle. So I'll make it like that. Okay, X, Y, Z. That's a 64 degrees given to you. Okay, now XY is produced. XY produced means it won't go that side. XY is produced, so you will produce it below. Okay, XY is produced to a point called as P. Okay, ray YQ, there is bisect ZYP. ZYP is this angle, so there is a ray which will bisect, meaning divide into equal parts. Okay, so that's YQ. Got it? So these two angles will be equal as it's bisecting. Okay, students, I hope that's clear now. Fine. The figure, and then I have to find all these things. So let's start. How will I do? Now, as this ray, this XY has been produced to P. Yeah, so XP is a line. Can I say that thing? Yeah, so angle XYZ plus angle ZYQ plus angle QYP. That's 180 degree. Okay. This I can assume they are, let's say, not X because X already there. A. Both are A. So XYZ is 64 plus A plus A 180 degrees. Why AA? Because they both are equal. QYQ is bisecting it. Okay. 64 plus 2A is 180. So what is 2A? 180 minus 64. What will we get after subtracting? It's 6. 7 minus 6 is 1. 116 is 2a, so a is 106 by 2, which is 58 degrees. So this is 58, students. This is also 58 degrees. Okay. So I got these two. So what will be ZYP? ZYP is actually 2a only, yeah? A plus a. So that'll be 116 degrees only. Fine, students. Let us check also if we have subtracted it correct. 10 minus 4 is 6. 7 minus 6 is 1. 1. Correct. That's correct only. Fine. Now I got ZYP. First thing. So that I don't have to find out also. Okay. I thought we have to find. So no problem. We have to find X, Y, Q. Okay. We have to find X, Y, Q. So X, Y, Q will be what? So angle X, Y, Q is XYZ plus ZYQ, which is 64 degrees plus 58 degrees. How much is that? 4 plus 8, 12. 1 carry over. So 122 degrees. Clear? We got XYQ. Correct. And then we have to find the reflex of QYP. QYP is 58. So I hope now you know what's the reflex of QYP, students. What's the reflex of that? 360 minus angle QYP. So what was QYP? QYP is 58 degrees. Okay. So let's subtract it. So 10 minus 8 is 2. 5 minus 5, 0. And that's 302 degrees. That's the reflex. Fine, students. I use this straight line thing, 64 plus a, 180, you got a. When you got a, you can find xyq, which is 64 plus 58. Okay, and then reflex of any angle is 360 minus that angle. Okay, so we did that also. So students, I hope you understood everything very well. Please practice it, follow the steps, write the reasons everywhere. Okay, because if you miss a step, you won't write the reason, you will lose marks. Whenever there a figure has to be drawn, write proving question is there, write what is given, what is to prove, and do the proof properly. Okay, and I hope you all understood it everything very well. Thank you for watching the video, and I'll come up with next exercise soon.